Hello everyone, this is from Focus Time. Today we are going to discuss the second example regarding to the hyperplane. So here we are using a MMC to find hyperplane, which is come under the nonlinear SVM. The first example, which is about linear SVM, the super vector machine, but here in the second example we are discussing about non-linear. So how? So let us consider an example. So the points are 2, 2, 2, minus 2, minus 2, minus 2, minus 2, 2, which comes under positive data points or group. And the negative points are 1, 1, 1 minus 1, minus 1, minus 1, minus 1, 1. Negative group. So after this, the first step that we have to follow is plotting these points on the x and y plane, right? XY plane, you have to plot it. So now, this is x and y plane, right? So let us point out the first point, that is 2, 2. So 2, 2, which comes here, which is a positive, right? Next, 2, minus 2, which comes here. And minus 2, minus 2, which comes here. These are the positive groups, which comes under the positive group. And the last one is minus 2, 2. Minus 2, 2. Fine. So, what are the negative points? 1, 1. 1, 1. So, this is a negative one, right? So, 1, minus 1. So, these are the negative points. Next, minus 1, minus 1. So, these are the negative points. Next, minus 1, 1. So, minus 1, 1. So, this is a negative point. So, from this, we can say that as positive and the negative groups are overlapping, and our goal is to discover a separating hyperplane. But here, though I perform any separating hyperplane, if I put separating line at this point, we cannot separate positive or negative, or in this direction I cannot separate a positive or negative groups, right? So therefore, we must use a non-linear SVM method. So which helps to convert the non-linear to linear, and again the points will get changes, and then after that again we have to plot xy plane. After that we are performing the same method. So let's get started. So this is a formula which helps to convert the non-linear to linear points. So if x1 square or plus x2 square, which is greater than 2, then you need to perform this 2 step. If it is lesser or equal to 2, then you have to write x1 and x2 as it is. Like how? So if I consider 2, 2. So this as x1 and this as x2. After performing this formula, x1 square plus x2 square, substituting 2 square plus 2 square greater than 2, then you have to perform this. So let us consider the first point, which is 2, 2. Let us write down the positive group first, which is 2, 2. Write down the positive groups, which comes under 2, 2, 2, minus 2, minus 2, minus 2, minus 2 and 2. So these are the positive groups, right? So as I've already told, square root of x1 square plus x2 square greater than 2. If this satisfies, you have to follow the next 2 steps, right? Now, square root of x1 square is, I am considering the first point, 2, 2. So x1, this is x1 and this is x2. So x1 is 2 square plus 2 square, which is nothing but square root of 8, which is greater than 2. So if it is satisfied, then you have to follow the equation 4 minus x2 plus x1 minus x2. Now 4 minus x2 is nothing but 2 plus 2 minus 2, which is nothing but x1 minus x2. x1, x2, 2 minus 2, which is equals to 2 plus 0, which is equals to 2, which is 2. Now the second thing is 4 minus x1 plus x1 minus x2. So 4 minus x1 is also 2, x1 minus x2. Again you will get 2 plus 0, which is 2. So the point for 2, 2, we got the same 2, 2. No changes in these 2 points. So the same thing you are going to perform for 2 and minus 2. Square root of x1 square plus x2 square greater than 2. So this is the formula. Now square root of x1 square is 2, x1 square, which is nothing but 2 square, plus x2. x2 is minus 2 whole square, which is equals to square root of 4, plus minus 2 whole square, which is also equal to 4. Therefore, square root of 8, which is also equal to 2. Same, square root of 8, which is greater than 2. Now, if this satisfied, if it is greater than 2, if it's satisfied, then we have to again repeat this step. 4 minus x square plus x1 minus x2, right? So 4, and what is x2? x2 is minus 2, right? So this is x1, this is x2. So minus x2 of minus 2 plus x1. x1 is 2 minus of minus 2. So what we're going to get? 4 plus 2, 4 plus 2 plus 2 plus 2, 2 plus 2. 4 plus 2 is 6 plus 4, which is nothing but 10. So this point has been changed. Again, second step is x1 plus x1 minus x2. Again, 4 x1. What is the value of x1? Which is 2. So 4 minus 2 plus x1 minus x2. x1 minus of 2, which is equals to 4 minus 2 is 2 plus 2 plus 2 is 4, which is equals to 6. Now the point from 2 to minus 2, 2 minus 2 to, it has been changed to 10 to 6. That means this is x, this is y. So 2 minus 2 to 10, 6. It has been changed. Fine. Now we are moving to the third point, that is minus 2, minus 2. If this is x1, this is x2, right? Minus 2 whole square plus minus 2 whole square, which is nothing but square root of 8, which is greater than 2. Now this condition satisfied. If this condition satisfied, again you have to repeat this step. So nothing but 4 minus x square plus x1 minus x2. So what does this says? 4 plus 2 plus minus 2, which is nothing but x1, plus 2, that is minus of minus 2, which is nothing but plus 2, that is equals to 6. 4 plus 2, 6, and this is 0, so remaining is 6. Fine. Now 4 minus x1, the second step, plus x1 minus x2, which is nothing but 4 plus 2 plus of minus 2 plus 2, which is 6 again. So the third point, 2 comma minus 2 comma minus 2, which is moved to 6 comma 6. So the values, the points has been changed here. Next, moving to the fourth point, that is minus 2, 2. So if minus 2 whole square plus 2 whole square, which is nothing but square root of 8, which is greater than 2. Am I right? So now 4 minus x2 plus x1 minus x2, which is nothing but 4 minus 2 plus minus 2 minus 2, because this is x1, this is x2, right? So x1 value is minus 2 and x2 value is 2. So as it is, the formula is minus, so the value remains the same, minus 2, which is nothing but 6. And the second step, x1 plus x1 minus x2, which is 4 plus 2 minus 2 minus 2, which is nothing but 10. So the points has been changed from minus 2 to 2 to 6 comma 10. Okay. So now moving to the negative points. So the first negative points that we have, that is 1 1, 1 minus 1, minus 1, minus 1, minus 1 and 1. So the same thing is repeated, square root of x1 square plus x2 square. This is x1, x2, square root of 1 square plus 1 square, which is nothing but square root of 2, which is lesser or equal to 2. That means we have already discussed, if it is lesser or equal to 2, you should write the same points, that is 1 comma 1. Fine. Next, moving to the second point, that is 1 minus 1, square root of 1 square plus minus of 1 minus 1 whole square, which is nothing but square root of 2, which is again lesser than or equal to 2. Again writing on the same point, that is 1 comma minus 1. Fine. So now, again considering the third point, that is minus 1, again 1 minus 1 whole square minus 1 whole square, which is nothing but square root of 2, which is lesser than equal to 2. Again the same points which is written here, minus 1, minus 1. Fine. So again the fourth point is minus 1, 1, minus 1 and 1, which is minus 1 whole square plus 1 square, which is equals to square root of 2, which is lesser than equal to 2. Again we will write down the same points, that is minus 1 and 1. Okay, so these are the negative points that we have got. So the positive points that we have already written, so this is the negative points. Now taking these 2 points, again we are going to repeat the previous method which has been done in the previous video. If you want, you can go and check out. So these are the points that we have got after performing this operation, right? So using this formula, if this condition satisfied that you are going to perform for the each point, you have to perform this operation. This formula gets satisfied, then if it is the value which is got, which is greater than 2, then you are going to perform this 2 equation. If it is lesser than or equal to 2, then you are going to write the same points, right? So after getting the points, that is 2, 2, 10, 6, 6, 6, 6, 10, which is a positive group, and these are the negative group. After getting these 2 points, you are going to plot. So 2, 2, which is a positive group. So 2, 2, that we have marked with a star. So that we have marked with a star. Next 10, 6, 10, 6. So this is a positive. Next 6 and 6, which is positive. Next 6, 10, 6, 10, which is positive. Fine. So these are the positive group. 2, 2, 10, 6, 6, 6 and 6, 10. Fine. Now we are moving to the negative. 1, 1, 1 and 1. So this is a negative. Next 1 minus 1, 1 minus 1. So this is a negative. Next minus 1, minus 1, minus 1, minus 1. So this is a negative. And next minus 1 plus 1, minus 1 plus 1. So this is a negative. So now after placing a separating line, you can observe, that is hyperplane, separating hyperplane, you can observe the points, the data points which is separated, which is a linear SVM right now. So we can easily perform the next operation as we have done in the previous example 1, right? So if the points get separated, the positive points and the negative data points or the groups get separated with the help of the separating hyperplane. So now you can perform the next step. So the points which is towards or near to the hyperplane, I am considering 1, 1 and 2, 2. So these 2 points that I am going to consider for this particular problem. So which is near to this hyperplane, that is 1, 1 and 2, 2. So I consider this as S1 and this as S2. So S1 is 1, 1, S2 is 2, 2. So the same thing, super vector, we are considering 1 and 1. This 1 is a bias, 2 and 2, and this is a bias. So for this particular super vector, we are going to write the formula. The previous problem, there was 3 super vectors, so we have written S1 super vector with S2 super vector and S3 super vector. But here we have only the 2 S1 and S2, so we are considering the 2 equations. So this equation is a general equation that you have to remember. After that, this is equation 1 and this is equation 2. Considering equation 1, that is alpha 1 S1 plus alpha 2 S2 S1, which is equals to minus 1. Considering this, so alpha 1, which is written same, and S1 we know, which is 1, 1, 1, and S1 is 1, 1, 1. Next alpha 2 and S2 S1. S2 value is 2, 2, 1, and S1 value is 1, 1, 1, which is equals to minus 1. And simplified form is 3 alpha 1 plus 5 alpha 2, which is equals to minus 1, which is equation 3. Again, for the second equation, the same thing. Alpha 1 is written as same, and the S1 1, 1, 1 value is given here, and S2 2, 2, 1 2, 2, 1 is given, and alpha 2 S2 is nothing but 2, 2, 1, same thing, it is given, and which is equal to 1. The simplified form is 5 alpha 1 plus 9 alpha 2 is equals to 1. So do you have any doubt in this thing? No. Next, moving on to next, from 3 and 4 equation, I am considering this 2 equation. The same thing, we have to cancel the terms. So to make it common, I am multiplying 3 with 5 because the next equation is 5. So 3 5s are 15, 5 3s are 15. To make it common, so that I can easily cancel the terms. Okay, so 15 alpha 1 plus 5 5s are 25. 1 into 5, which is minus 5. So same thing. So the signs should be changed. After that, the 15 alpha 1 and 15 alpha 1 minus 15 alpha 1 get cancelled. So the remaining term is 2 alpha 2, which is equals to 8. Then alpha 2 is 4. So we have got the value of alpha 2. Now, considering the equation 3, I am considering this equation. Using this equation, I can easily substitute this 8 by 2. This 8 by 2 value over here. So, 3 alpha 1 plus 5 alpha 2 is equals to minus 1, which is equation 3. Now, 3 alpha 1 plus 5, or you can write the direct 4 or 8 by 2, which is equals to 4, right? So, alpha 2, which is 4, equals to minus 1. So, 3 alpha 1 is equals to minus 21. So, minus 21 by 3 is equals to minus 7. So, you get alpha 1 is equals to minus 7. So, we have got the value of alpha 1 and alpha 2. So now we need to know the optimal hyperplane. So the formula is the sum of alpha I and Si, which is the sum of alpha 1 S1 plus alpha 2 S2. Alpha 1 is minus 7 and alpha 2 is 4 and S1 is 111, S2 is 221. So if you multiply 7 into 1 is minus 7, minus 7, minus 7. 4 to is 8, 8 and plus 4. If you minus 7 plus 8, which is equals to 1. So the same thing, 1 minus 3. How? Minus 7 plus 4, which is equals to minus 3. As I've already told, it is an offset, and this is belongs to x, this belongs to y, and this is an offset. We need to neglect the negative sign here. So finally, the vectors are augmented with the bias. Hyperplane equation is y is equals to wx plus b. W is nothing but x and y, so you have considered here, and b is the offset, that is minus 3. So neglect the negative sign and plot on the graph. So the positive 3 and on the x-axis and on the y-axis positive 3. So you have to mark and plot the graph. So this is the final output or the step for the particular problem using MMC in order to find the hyperplane. So this is about the non-linear, how to solve the problem when the given data points are non-linear, and how to convert to the linear terms and perform the operation as given based on the linear terms. So if you have any doubt, please do comment on the comment section. Thank you.